In this video, I'm going to talk about dot convention. What is dot convention? This dot convention will tells us the orientation of the coil in a transformer. Say for example, we made the transformer in the lab last week. So if you look at it, if you wind the coil, both coils in clockwise direction, then induced EMF in the second coil is going to be, one terminal is going to be positive, another terminal is going to be negative. So based on your orientation, whether you did this winding in clockwise direction or you did this winding in the anti-clockwise direction, based on that, this positive and negative, positive hot wire and ground wire is going to be defined, okay, or positive wire and negative wire is going to be defined. That orientation we can define, or the manufacturer defined, by using a dot convention. So it is defined based on the orientation of the coil, and it tells us which terminal of the secondary is positive. It talks about which terminal of the secondary is positive. So if current is entering the dotted terminal of the first coil, then the dotted terminal of the second coil is positive. So this is really important point we need to remember when we are doing the dot convention. If current is entering the dotted terminal of the first coil, then the dotted terminal of the second coil is positive. Say for example, I have dot here and another dot here, okay. So here, if current is entering the dot, here if the current is entering the dot, so I1 current is entering the dot, I1 is going in the direction based on the V1, right? So V1 is positive, negative here. The V1, the I1 is, the direction of the I1 is based on the V1, okay, V1 orientation. So I have positive up there, so I1 is leaving that V1 source because we are connecting a source here. The source is going to have positive. Now, if the current is entering the dotted terminal according to this statement, then the dotted terminal of the second coil is positive. So here I have a dot, so that means the orientation probably is in the same direction. So this is going to be positive, negative, that is our V2. Okay, that's what it talks about. So for sure, the secondary coil of the transformer is going to act like a source for this circuit, for the load basically in this case. So current is going to leave the positive terminal there, okay. So this is positive and negative. Now the second statement is just opposite. Say for example, if I have the dot in the opposite side. So in this example, I'm in the same transformer, I made it as ideal transformer. So current is entering the dotted terminal, the dotted terminal of the second winding is going to be positive. So here we'll have V2 and current is going to go out of this terminal V2. Now the second statement, if current is leaving the dotted terminal, say for example, in this example here, the manufacturer who defined the dot is defined by the manufacturer, okay. So here is the dot, current is entering the dot, in the sense, my meaning is the dot is at the entrance of the inductor. So here, see, current is entering the inductor and the dot is at the entrance of the inductor. That's what I meant to say. If current is entering the dot, that means the dot is at the entrance of the inductor. Now here, current is leaving the dot, that means the dot is at the end of the inductor, okay. So here I have V1 and I1. Since current I1 is leaving the dot, I didn't put the dot here. Suppose, say for example, the dot is right there. So these dots are defined by the manufacturer. So the manufacturer knows how he oriented the coils, whether both of them are in clockwise direction or one is anti-clockwise, one is clockwise. Based on that, he defines those dots. So here current is leaving the dot, so the dotted terminal is going to be negative, okay, and the current is going to go in this direction, okay. So this is about the dot convention. Now I'm going to solve some simple examples here. Okay, here is an example. In this example, he gave us the transformer ratio, okay, 1:5, which is turns ratio in this case. Now, the current I1 is leaving the dot, so the dotted terminal is negative. So, I mean, it's supposed to be negative and this supposed to be positive. He already defined this as negative, so we're good. So when you calculated, you end up with negative and positive, and he also gave you the same thing, positive and negative. So when we write the transformer ratio, which is V2 over V1 equal to, you will end up with a 5/1, okay, with the positive sign there. Why I put positive, you will see in the next example. Now, the current I2 supposed to leave this positive terminal all the time, okay, whatever the new positive terminal you assume. So my I2 is leaving that terminal, so basically I1 over I2 is also going to be plus 5/1. Now, say for example, he gave you in the opposite side. So here is another example. In this example, it's a 1:4 ratio transformer. Now, according to our calculations, we'll find our V2. Now, current is leaving the dot, so the dotted terminal must be negative. Okay, so V2 you must have a negative there and positive here, and your I2 supposed to leave this terminal. Okay, whatever you found, it has to leave that terminal. But the author already gave you this terminal as positive, okay, which is opposite to what you found. Okay, so when you find the ratio V2 over V1 equal to 4/1, take this V2 as a negative value. Okay, so that's the reason I put the positive there. I mean, if I rearrange this, V2 over V1 equal to negative 4/1. That is the transformer ratio. Okay, again I'm explaining one more time why I got this negative, because he gave you this plus and minus V2 across this secondary coil. Okay, now you calculated, or you found by using the dot convention, you found that this terminal supposed to be negative, this terminal supposed to be positive. Okay, this is you found this, the original V2 supposed to be like this. So the bottom one must be positive, top one must be negative. But the author already gave you bottom one is negative, top one is positive. So which is opposite to the calculated value. That is the reason I'm taking this as V2 over V1 equal to minus 4/1. Okay. Now same way we'll look into the I2. So we know that I1 over I2 equal to 4/1 here also. Now the current I2 supposed to leave this terminal. Okay, this is the terminal you calculated or you found by using the dot convention. Okay, so I2 supposed to leave this terminal, but he gave you I2 leaving this terminal. Okay, so which is opposite to the your calculated one or found one by using the dot convention. So your I2 must be negative here. So I1 over I2 equal to negative 4/1. Okay, so that's how the dot convention is useful to find out the orientation of the coil, or which terminal of the secondary is going to be positive, which terminal of the secondary is going to be negative. Okay, this is about dot convention. In the next video I'll talk about the auto transformer. Thank you.